Okay, we're at the last section of the notes, so let's get rolling. All we're going to do is take everything that we did so far this unit, or this half unit, and we're going to pull it all together. So basically just continue practicing the stuff that we've done before. So we want to identify the vertical asymptotes, horizontal asymptotes, slant asymptotes, holes, domain, range, increasing, decreasing, x-intercepts, y-intercept, and sketch the graph. Now, one of the things that I am going to take off of here, because we do not have our calculator for this, is we're going to take off range because we're not totally sure how high or low these are going to go. There might be points of discontinuity. There might be horizontal asymptotes, but then if we hit the horizontal asymptote, then it's going to change the range on the graph. Far more accurate if we have a calculator in our hands. Same thing with increasing and decreasing. But do keep in mind the way that we calculate or locate those things is the exact same way that we did before. So if I provide you with a graph with a ton of points on it, you need to know how to find all of those points, increasing, decreasing, range, look for the things where the graph does not exist, so on and so forth. I think everything else is doable though. Okay, so we're going to start the exact same way that we have before. We're going to go ahead and take the function that was given to us and let's start factoring. So I'm going to take a look at this. I think the bottom is factorable. That's going to give me a 2x and an x. And I think I get a minus 5 and a plus 4 if I drag this over. Okay. If you take a look at the top and the bottom, those are almost identical. The only difference is that there is a negative sign difference on all of them. That tells me that chances are those match. So I'm going to go ahead and take a negative 1 out of the top and turn that into a 2x minus 5. And then a 2x minus 5, x plus 4. Okay, now I can actually see that there's actually a hole here. All right, let's start identifying all of our stuff. So vertical asymptote, hole, horizontal asymptote, slant asymptote. Okay, let's see. Vertical asymptote. Well, I'm going to do the hole first. So the hole is going to give us, it's going to be at x equals 5 halves. Remember, we're going to set that equal to 0. Okay, so my hole is going to be at 5 halves, comma, something. I don't really know. So we're going to take our new simplified version of the equation, which is now going to be negative 1 over x plus 4, and I'm going to plug my 5 halves into it. Okay, no calculator, so I gotta make sure that I can do this. Okay, 5 halves plus 4. Well, 4 is 8 halves, so that's 13 halves. And then negative 1 divided by 13 halves is negative 2/13. Okay, so the hole is located at 5 halves, which is 2.5, and then common negative 2/13, which is really just slightly smaller than 0. Okay, then let's take a look back at this. Let's look for the vertical asymptote. Well, there's a vertical asymptote at x equals negative 4. Remember, it is the thing that makes the denominator 0 after the hole has been removed. So I have x is equal to negative 4. Okay, horizontal asymptote. I'm going to go back to the original. Let's take a look at the degree of these things. Okay, so the degree of the top is 1, and the degree of the bottom is 2. So that means that the bottom is growing faster than the top is growing. So if the bottom of a fraction is getting bigger in comparison to the top of the fraction, that means that this fraction value is approaching 0, which means my horizontal asymptote is at y equals 0. And then we got to figure out if we're going to hit that thing. Y equals 0. Let's go ahead and fill in D and E. For slant, remember you can't have a horizontal and a slant at the same time. Okay, let's see if we actually hit the horizontal. So we're going to do 0 equals, so replace the y values, go back up to the original. So we've got negative 2x plus 5 over what the original problem was, which is 2x squared plus 3x minus 20. I'm going to cross multiply here, wipes out that guy on the bottom. Let's get rid of that. So I'm going to get 0 is equal to negative 2x plus 5. If I solve, that's 5 halves. However, if I compare that, x value of 5 halves, it's a hole. It's right there. So remember, if the x answer you get when you plug in the horizontal asymptote corresponds with either the vertical asymptote or the hole, that point's already taken. That x value is already accounted for. So we cannot have, so we will have a graph does not intersect horizontal asymptote. Okay, now we know. And then we need to find more points. Okay, so vertical asymptote, horizontal asymptote, slant, holes, domain. We'll get to that in a second. X-intercepts and Y-intercept. Okay, let's do that. Okay, so to find the X-intercept, we're going to plug in Y equals 0. Remember when we do that? All you're doing is paying attention to the top of this thing. And I think that's going to give us x is equal to 5/2. Okay. So if we have an x-intercept, x is equal to 5/2. 5/2 is already accounted for. So we don't have one because this x value matches with that hole. So that's a no. Okay, so x-intercept we have does not exist, which we already realized anyway, because if the horizontal asymptote is y equals 0, y equals 0 is the x-axis. We already figured out that you can't hit the horizontal, but if the horizontal is the x-axis, then you can't have an x-intercept. Like, we already figured that out. Maybe a little bit more work than we needed to do. All right, let's do the y-intercept instead. Okay, y-intercept, we're going to go back. Remember, plug 0 in for all of the x's. We don't have to do a ton of work on this. This one automatically turns into whatever the constant was on the top over whatever the constant was on the bottom. So this is going to give us 0, comma, it looks like we get negative 1/4. Okay, let's see if we have enough points to actually graph this thing. So get your XY axis set and ready to go. Let's see here. Oh, too high. And then since that's the horizontal asymptote, I'm just going to go ahead and erase pieces of it. All right. And then I have a vertical asymptote at x equals negative 4. Let's put that on there. So 1, 2, 3, 4. So that's this guy. And then I'm going to have a hole in the graph at 2.5 and just slightly lower than 0. So 2.5, 1, 2.5, slightly lower than 0, somewhere over there. Okay, so if that graph is over there, then I don't hit the horizontal, I already figured that out. I already have a good idea of what this thing's going to look like. Plus, I have the point 0, comma, negative 1/4. So down there somewhere. Okay. Let's see, give it a decent sketch. Okay, now we have to figure out where the rest of this thing is. So remember, it can't be there because then it wouldn't be a function. It could be there, or it could be there. So all we have to do is pick a point that's left of the vertical asymptote. Okay, so the vertical asymptote's at x equals negative 4, so let's just plug in x equals negative 5. So I'm going to plug in x equals negative 5. All the way back into the original. Let's see what we got. So let's see. Plug in x equals negative 5. It's going to be negative 2 times negative 5 is 10. 10 plus 5 is going to go on the top. Negative 5 on the bottom. Negative 5 squared is 25. 25 times 2 is 50. And then minus 15 minus 20. I think it's going to be 15 minus 35. Oh, 15 over 15. I think that's 1. So we're going to have negative 5, comma 1. All right, that's a nice point to plot. Oh, and now we know where we are. We're up. Not going to hit the horizontal asymptote. We already figured that out. Definitely not going to hit the vertical asymptote. Okay, so now domain and range. Well, domain we can do for sure. So domain, what color have we not used? I don't think we've used blue. Okay, so the domain is always going to be coming in from the left and going towards the right. You can do this in interval, or you could just say all real numbers except where the x doesn't exist. So in this case, I think I'm just going to say my domain is all real numbers, but x cannot be where the vertical asymptote, for sure, that's -3, -4, -4. And at the x location of the hole. Remember, there's our x values, so 5/2. But everywhere else, it's going to exist. So there's my domain. Okay, let's see if you can do the whole thing, start to finish. So, quick rundown. Factor. Look for holes in vertical asymptotes at the same time. Remember that a vertical asymptote is x equals, a hole is a point, so x comma y. Then, horizontal slant. Look for the degree of the top, degree of the bottom. If there's a horizontal, there can't be a slant. If there's a slant, there can't be a horizontal. Then, see if you can find the x-intercepts, the y-intercept, like the whole shebang. See if you can do the whole thing. Pause it now. So the next time after you pause, I'm going to have the whole thing worked out. Graph, domain, x-intercept, y-intercept, everything. Let's see what we can do. Okay, let's see how you did. So I went through and I factored. Then the first thing I did was the blue. So I found that the two factors on the top and bottom, x minus 3 match. That's going to give me a hole. So the x value of the hole is 3. Then continuing in blue, I plugged 3 back into the simplified version of the equation. And I get 3 plus 2 on top, which is 5, and 3 minus 1 on the bottom, which is 2. So I got 5/2. So now I've got the location of the hole, which is 3, 2.5, or 5/2. After I did that, then I went back and I ignored the blue and I only looked at the denominator that didn't match something in the bottom, so that's x minus 1. So that means I'm going to have a vertical asymptote at x equals 1. Then I went back to the original version of the equation, not the factored version, and I took a look at the degree. Notice that the degree of the top and the bottom are exactly the same thing, which means that, let's try it again. Which means that the horizontal asymptote is going to be the leading coefficient on the top over the leading coefficient on the bottom. Both of them are 1, so I get y equals 1. Then I did a quick check. Am I actually going to intersect the horizontal asymptote? I plugged 1 in for y into the original equation, cross-multiplied, solved, and I got x is equal to 3. But x equals 3 is already accounted for. That is the x value of the hole, which means you're not going to cross the horizontal asymptote. So then after that, I thought, okay, well, if I have a horizontal asymptote, there's definitely no slant, so that's a D&E. And then I just needed to find the x-intercepts and the y-intercept. Once I find the x-intercepts and the y-intercept, I notice that one of the x-intercepts is technically a hole, so I'll cross that guy out. Then I kept the x-intercept that I had. It actually gave me enough to be able to plot the points and to graph then that left bottom portion of the graph. Once I found the y-intercept, but then after that, I had the hole and I figured, I may as well just find one more point and see what I can get out of this, a pretty decent sketch. And then after that, after I found my sketch, I then identified my domain. Domain is everything except for where the x doesn't exist, and the x does not exist at the vertical asymptote. It does not exist at the hole. So there's our complete answer to this question. Okay. Try it again. Now, just remember, just because I give you a problem like this doesn't mean that something is always factorable. All right, it's been a bit since we've done that. So you're going to go through and do the exact same process. Look for the holes, vertical asymptotes, the entire list of things that you're looking for. Pause this, and then you might want to stop partway through when you start looking for the holes in the, with the horizontal asymptote and the slant. Because we do, if you look carefully right now, we see that the degree of the top is 1 bigger than the degree of the bottom. So you're going to have to find a slant asymptote. So maybe flip back to your previous notes on this. Find your slant asymptote and then proceed. Remember, the graph could also cross a slant asymptote. So you have to make sure that that does or doesn't happen, because if there's a point on there, we want to actually have it. Okay, I'll stop. Pause the video. See if you can do the whole thing beginning to end, and then come back and check. Okay, check your answers. The top was not factorable, so there were no holes. Vertical asymptote is x equals -1. Horizontal asymptote does not exist because the degree of the top was bigger than the degree of the bottom, so the top of the fraction is blowing up. It's growing way faster than the bottom does, and the bottom can't catch it, so this thing's blowing up to infinity. Okay, so then there's a possibility of a slant. Remember, slant only exists if the degree of the top is bigger than the degree of the bottom by 1, and when you divide, there is a remainder. No remainder means it would have gone in evenly, which means you had a whole actually. So we ended up with y is equal to 2x plus 3. But then remember, there's a possibility that you can cross a slant. So you have to plug it back in for your y value, see if you actually cross a slant. In this case, that doesn't happen. So then I went through and I found the x-intercept, but the x-intercept only comes from the top of the fraction. And I did a quick b squared minus 4ac to see if I should even continue with trying to solve this thing. And no, because it's imaginary and we're only dealing with real numbers right now. Then the y-intercept, not too bad. Actually, plugging in 0 is kind of nice. And then I wanted to find one more point because I did not know where the graph was going to be. So I plugged in one more point. Now, I know this is where the notes end. However, there is one more that I want to add in here, and it's when you have multiple vertical asymptotes. I want you to see what you're supposed to do or how to handle this. And mostly the process is the same. So here we have number 4. I want to add this into your notes. And we have our new function, f of x equal to x over x squared minus x minus 2. So I want you to proceed the exact same way that you did. So go through, find your vertical asymptote, find the horizontal asymptote, Apologies if I'm repeating myself. We're going to go through and do the exact same thing, though. So go through, find everything that you're supposed to find. And then when it gets to the point where you're starting to graph, go ahead and put your vertical asymptotes on there, horizontal asymptote, slant if you have it, whole if you have it. And then I will pick up and help you with the graphing part. So get yourself up to that stage. So pause, get yourself up to that stage. And then when you're ready to start graphing, you've got your asymptotes, holes, everything on the graph. Go ahead and not restart, but take me off pause, and then we can continue this together. Okay, so in this case, we actually have 2 vertical asymptotes. With 2 vertical asymptotes, you've definitely sectioned your graph into 3 vertical locations. So left of the vertical asymptotes, between the vertical asymptote, to the right of the right vertical asymptote. Then with the horizontal asymptote coming into play, we don't have a slant here, then you've now created basically 6 sections here. But since we're crossing the horizontal asymptotes, if you plug in 0, you can get a value. We need more points because there's no way this is what the graph looks like. All I have is my vertical asymptote, horizontal asymptote, and a single point on the graph. Not sufficient. My recommendation to you at this point, so when something like this happens, pick a point to the left of the vertical asymptote. So if the left vertical asymptote is x equals -1, pick x equals -2. Okay, so let's make a little table here. So ideas of numbers to choose. -2 seems valid. I already know it's not going to hit the horizontal asymptote over there because I would have already figured that out. So -2 is where it's going to hit the horizontal. Well, let's try that again. Wow. At x equals 0 is where you hit the horizontal asymptote. Okay, so now wherever x equals -2 gives me -2 comma, it's going to tell me if I'm like up above or if I'm down below over here. Then I'm going to pick like a handful of points in here. So right here in the middle, because of that point, I don't know if the graph is just going to like go up there and hit it and come down, or if the graph is going to do like some weird funky business. I have no idea what's going to happen. So we're going to have to pick a couple points in there. So let's see. Let's do -1/2 and 1. Okay, so let's do -1/2 and 1. So this is basically left. This is middle. Just trying to figure out what it looks like in all the places. And then let's pick one thing to the right. So if the vertical asymptote on the far right is located at 2, then let's pick 3. So, we don't want that to be -1. We want that to be +1. My apologies. So now plug those in, see what you get. See if we can get some more points on this thing. Okay, so when I plugged in -2, you can see my work at the bottom. -2, I got -1/2, so I plotted that point. And then just remember, like this purple thing is my x-axis. Then for the middle, plugged in -1/2, I got 2/5. 1, I got -1/2, and then 3, I got 3/4. Remember, you don't have a calculator on this, so make sure that you're practicing your fractions. Now that I have those points, and I know that I cannot hit a vertical asymptote, I already know where I'm hitting the horizontal asymptote, I should be able to sketch this thing. So this point looks like it's going to be give me a curve down here. And with this, I have a pretty good idea of what's happening in the middle. Honestly, it kind of looks like a little cubic. You can plot more points if you're not convinced. And then this guy over here, so it's gonna curve. Don't hit that. Okay, now, so remember, if you have multiple locations with your vertical asymptotes, then you're looking at multiple sections. You're gonna have to find extra points within those sections. Okay, now we're done.